Well, let me start things off by thanking you all for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models, including the very latest models incorporating new cutting-edge technology, which we're going to look at those in just a little bit. Now, over the years, I would typically begin these presentations with a discussion of the importance of STEM education, talk about changes in the manufacturing environment, and the growing need for highly skilled workers in the modern workforce. But as I think at this point, it's pretty much well established just why technology-focused education is so important. And with that in mind, I'm going to dispense with any preamble on that and jump right into the discussion of what fischertechnik is, and then I'm going to show you each of the current models that are available in the simulation family. Now, fischertechnik simulation models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line itself consists of a series of pre-assembled small-scale models, which are designed to replicate both in appearance and function various automated robotic machines and systems that are commonly used in commercial manufacturing. But before we look at any of these models, I'm going to provide you with just a little bit of background. fischertechnik has been creating tools for teaching students of all ages about technology and how things work for well over 50 years, actually almost 60 years at this point, all based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to simply stack, the fischertechnik system was created with more of an engineering mindset. And what I mean by that is if you see the core building block that's shown on the screen now, you'll see that it's designed to enable attachment from all 6 sides. And because of this, it allows for almost limitless design possibilities. Many of the parts, like the parts you see on the screen right now, are designed to slide together and lock in place using a tongue and groove assembly method. And because there are hundreds of different parts available, it'll also help technical builders to address very specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who's of course shown on the screen now, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime, which is fairly impressive. Now, prior to creating fischertechnik, Mr. Fischer was first noted as the inventor of synchronized flash photography, and that was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, continues to employ thousands of workers around the globe, producing many variations of fastening devices used in building construction, and they also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik building sets, whether it's those intended for the retail market or those meant for the classroom, has always been on fostering an understanding of technology. Many of the products offered by fischertechnik for the education sector are what we refer to as subject-specific sets, focusing on different STEM-related topic areas, things such as mechanics, pneumatics, robotics, renewable energy, and so on. Many of these sets either include curriculum or they include detailed teaching and activity materials. And in most cases, students are going to be asked to build a progression of models using the unique fischertechnik building system, and then they perform various experiments which allow them to explore and understand key aspects of the subject at hand. But the line of fischertechnik simulation solutions, which are, of course, the focus of today's presentation, are something much different. This line consists not of kits, but of a series of pre-assembled small-scale models, which again are designed to replicate in appearance and function various automated robotic machines and systems. Some of the models you'll find in the fischertechnik simulation line include things like conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and high bay warehouse storage systems. Now, besides these individual models, which of course focus on specific automated processes, Fischer Technic also offers several variations of an integrated factory simulation model. Now, these factory models consist of 4 individual workstations, a vacuum gripper, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection designed to all work together as one self-contained material cycle. And of course, we're going to look at these models in detail during the course of this presentation. Now, before we get into any of that, I'm going to very briefly outline some of the advantages of using Fischer Technic simulation solutions. First, Fischer Technic simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate in both appearance and in function common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact, and in most cases tabletop size, they're not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next aspect is quality. Each Fischer Technic simulation model is hand-assembled, and it's a high-quality German-made product. Each of the models we're going to look at is available in a 24-volt version for industrial users, with some select models also available in a 9-volt version for those not versed in or involved with the programming or use of PLCs. The 24-volt versions are always designed for use with industry standard PLCs, and it shouldn't matter whether you use Allen Bradley controllers, if you prefer Siemens controllers, or if you prefer controllers from manufacturers like Honeywell, Mitsubishi, General Electric. You could probably name many others. In any of these cases, you can control the 24-volt versions with the modern PLC, which you prefer. Now, likewise, just as you can use your choice of controller, you can also use your choice of your preferred programming language. Whether you like ladder diagram or structured text or what have you, you can choose the language that's going to work best for you. But the one thing I do want to mention is that with most of the 24-volt versions we're going to be looking at, no PLC is actually included. And any programming or programming guidance, as well as power supplies or additional hardware, are going to be the responsibility of the end user. Now, there are going to be a few exceptions to this, which I will note, but in most of the cases, especially the models we're going to be looking at in the early part of the presentation, keep that in mind. These are going to be the models themselves, so any additional wiring from the model to your PLC connection board, of course, your PLC itself, and the programming, any of these languages which you decide to use to program the models or control the models, that is something that you would have to create and be responsible for on your own. Of course, this should not be an issue, as again, these models are designed specifically for industrial users or for those who are involved in teaching or exploring industrial processes involving PLC programming. But as I touched on before, there are also 9-volt versions available of select models, and I'll mention it as they come up. Now, these 9-volt versions will ship pre-wired to Fischer Technic's own proprietary robotic controller, which is called the TXT controller. And in the case of these 9-volt models, each controller is pre-programmed using either Fischer Technic's own RoboPro-graphic programming software. It's their proprietary software, or in some cases using C++. Now, in the case of any of these 9-volt models, the only additional component required by the end user would be a simple 9-volt power adapter, which we do sell. Otherwise, these are essentially ready to use out of the box. Now, if you're involved in demonstrating or exploring IoT, of course, known as the Internet of Things, besides the fact that many end users have adapted many of the models in the Fischer Technic line to use them for IoT purposes on their own, But now fischertechnik also offers several special IoT-focused versions of the factory simulation, which are designed specifically for exploring and understanding cloud-based control and what's often referred to as Factory 4.0. Now, in the case of these IoT models, the model is designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to discuss all this in more detail just a little bit later in the presentation. Finally, fischertechnik simulation models are cost effective. Now, I can't stress this enough, but if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice pretty quickly that the entry point for many of these products can easily be $30,000 to $40,000 or even more, and that's the entry point. Now, fischertechnik simulation solutions, on the other hand, start off at just a fraction of that price, as well as, again, being compact, realistic, and high-quality learning and demonstration tools. So with all that being said, let's begin our look at each of the models which are currently available. Now, we're going to begin by looking at some of the more basic modules, and we're going to work our way up to the larger factory models, which I kind of talked about already, which will consist of, again, several workstations designed to showcase an entire production cycle. So we're going to start off with a look at one of the classic line of fischertechnik simulation models, and this is a very basic conveyor belt. Now, what you're looking at here is a transport belt with a length of 275 millimeters that's used to transport work pieces with a diameter of up to 29 millimeters. Now, multiple conveyors can easily be connected to increase the length of transport as you may desire. Some of the components on this model will include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of this model are approximately 14 by 10 by 4 inches, and it has a total weight of under 2 pounds. The model itself is available in both a 24-volt version with a multi-pin connector, and that would be 26 pins with a 2.54 millimeter grid as seen here. And again, the 24-volt version of this model, as well as many of the 24-volt versions we're going to look at this afternoon, will require you to provide your own PLC and your own programming. But as I was mentioning before, there's also a 9-volt version in this case, which is connected to a pre-programmed robotics TXT controller as shown here. And again, you would need one 120-volt power adapter for operation on this. And I will mention that for this and for all of the other models we're going to look at today, you can also find detailed specs on the Studica website and also the fischertechnik.biz website. So if you want to have the specs for any of these models, I'll of course mention things as we go through this. But if you do want specs, they are on the product listings. And also I will give you some email information at the end. So if you wanted to get specs on anything, and if you perhaps can't find it on the website, you can just email me and we'll be able to get that for you. Now, the next model we're going to look at is the punching machine with conveyor belt. And it's basically a variation of the conveyor belt we just looked at, except this time with a machining station built onto it. Components on this model include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. The dimensions for the model are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. And it's again available in a 24-volt variation with the 26-pin connector and the 2.54 millimeter grid as shown here, and a 9-volt version wired to the robotics TXT controller, which again requires the 1 power adapter for use. The next model we're looking at is an index line with 2 machining stations, and this model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Other components on the model include 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, it's available in both the 24-volt version with a 26-pin connector and a 2.54 millimeter grid, for use with PLCs. and also the 9-volt version wired to the pre-programmed robotics TXT controller, actually two TXT controllers as you see here, and will require two 120-volt power adapters. The next variation we're going to look at is on the idea of a pick-and-place robot. It's what they call the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in three-dimensional space. The degrees of freedom for this robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or back 90 millimeters, and axis 3 can raise or lower 150 millimeters. Components on this model include 2 XS motors, 2 encoder motors, and 4 push-button limit switches. And the dimensions of the model are approximately 19 by 16 by 9 inches. It has a weight of just about 6 pounds. And as with the other models we've looked at, this one is again available in both a 24-volt version with the 26-pin connector and 2.54 millimeter grid, designed for use with the PLC and the programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller, and again, requiring one 120-volt power adapter. The next model we're looking at is the vacuum gripper robot. And starting here, we get to show you the models in action. Now, as you're going to see here, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in three-dimensional space. It includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. The dimensions of the model are approximately 9 by 19 by 15 inches, and it has a weight of just about 7 pounds. The 24-volt version of this model, as well as all of the 24-volt versions we're going to be looking at moving forward, each have a relay board for motor polarity reversal and both a multi-pin connector. This time it's a 34-pin connector with a grid of 2.54 millimeters, as well as additional PCB terminals with push-ins connections for all inputs and outputs. Again, the 24-volt version of this model, as with all 24-volt versions we've looked at so far, will require you to provide the PLC and the programming. We'll just let this play through. And there we go. The next model we're looking at is the automated high bay warehouse. And this model that you're going to see here features a transfer station with a conveyor belt along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays and 9 individual storage spots for the workpieces. Components that you're going to find on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, along with a selection of different colored workpieces and carrier trays for each piece. I will mention that this model seems to be a favorite among educators that I've spoken with who deal with teaching PLCs and PLC programming. And the reason that they like it so much is because it gives students a lot of very specific coding tasks that they need to address. The precision with which the pieces must be picked up from the little conveyor system that you see over here, moved with the picker arm onto the different shelves. That takes a lot of very specialized programming, and because of that reason, they like it a lot. Getting back to the model, the dimensions of the model are approximately 19 by 28.5 by 15 inches, and it has a weight of about 18 pounds. Again, the 24-volt version has the relay board for motor polarity reversal and both multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, you need to provide your own PLC and programming, and there is a 9-volt version available. The next model in the line is the multi-processing station with oven. And the model you're going to see here features a furnace simulation with a pneumatic sliding door. You'll see there's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components on the model include 4 mini motors, 6 push-button limit switches, 2 phototransistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches. It has a weight of about 11 pounds. Again, it's available in both the 24-volt version for use with the PLC of your choice, with, again, a relay board for motor polarity reversal and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And the 9-volt version, in this case, is connected to 2 Robotics TXT controllers, and so you would need 2 120-volt power adapters with that. We'll let this play for just a second here. As it goes through the stations. And there we go. The next model we're looking at is a sorting line with color detection. And this simulation features a system, of course, for detecting work pieces of different colors, and it sorts them using the conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions of the model are approximately 20 by 14 by 12 inches. It has a weight of about 10 pounds. As I've discussed before, the 24-volt version has the relay board for motor polarity reversal and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, the end user must provide the PLC and the programming. And the 9-volt version will come pre-wired to a pre-programmed Robotics TXT controller, and one 120-volt power adapter is required. And the next model we're going to look at is the factory simulation, which combines the last 4 models we've reviewed, which is the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with oven, and the sorting line with color detection into one self-contained material cycle. And the cycle you're going to see will work like this. Work pieces get retrieved from the automated high bay warehouse using the vacuum gripper robot, and then they are moved to the multi-processing station with the oven. And after the workpiece has been processed by that machine, it's then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as I've already discussed the components of each model previously, I'm not going to belabor it by stating them here, but what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual models into one cycle, because of this, it has a much larger footprint. In this case, we're talking about approximately 39 by 31 by 16 inches in total, and it has a total weight of between 43 and 46 pounds, depending upon whether you're getting the 24-volt version or the 9-volt version, because of course, things that are put on there, controllers and what have you. Now, due to these dimensions, and because this, again, comes pre-assembled, please note that this model can only be shipped flat as freight on a pallet. And I also want to point out that several of these factory simulation models are in very high demand. And because of that, you can sometimes anticipate a turnaround time of up to 2 to 3 weeks prior to any orders for this model leaving our warehouse. Now, we do try to keep them in stock, So if you have any questions, feel free to connect with us, speak to your representative who would be quoting you on these. But if you were just cold calling us about one of these, there can be a little bit of a lag time on it. I will mention that this one that we're looking at right now, the regular version, is only available in a 24-volt version currently. We'll see some other ones that are available in 9 volts as well. Now, before we move on to the next group of models, I do want to mention that there is also a storage option available for the factory simulation model we just looked at, whether you want to transport the model or if you want to just protect it when it's not in use. And that's the travel and storage case you see here. The case itself consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model. And it also has 3 internal zipper pockets for storing cables and other accessories, things like the work pieces for the warehouse. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can still remain in the bottom section of the case and be fully functional. The case itself has exterior dimensions of approximately 41 by 33 by 17 inches, and the empty case alone has a weight of approximately 53 pounds. So just keep in mind that if you have the case with the model inside, with the factory model inside, you're looking at least 100 pounds, and some of the variations we're going to be looking at a little bit later would be even more than that. So a full case should be about, give or take, 100 to 120 pounds. One thing I need to note is that even when using this travel case, these models still need to always be shipped flat, and they have to be shipped on a pallet as freight, just to protect them from any kind of possible damage in transit. So please keep that in mind. Now, the next group of models we're going to look at will focus on the area of IoT, and these are what are referred to as the Training Factory Industry 4.0 models. The group of models was designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before you implement them on a larger scale. Now, as the following video provides a really nice narration and overview of just how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The Fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
So just to summarize things quickly here are some of the topic areas which can be addressed with the Fischertechnik Training Factory Industry 4.0. Of course, training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, the use and operating of dashboards, web-based remote maintenance, the linking of production and materials planning data, the connection of upstream and downstream logistics processes, and also the creation of your own unique programming using C, C++, of course, for the experts. Now, as you just saw, the model incorporates many features that aren't found in the models that we previously discussed, most notably being the use of the cloud-based dashboard for monitoring and controlling the model. But some other examples would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each workpiece enables the position of the workpiece in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, allows the network TXT controllers to communicate with one another. Now, in regards to the 24-volt version specifically, I should note that it's a bit of a hybrid in that while using a PLC for operation and control, it also incorporates one fischertechnik's robotics TXT controller. And in this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, also known as OPC Unified Architecture, is of course a standard for exchanging data across different platforms. Now, in addition to the TXT controller used here, there's also an IoT gateway using Raspberry Pi with Node-RED. And this allows the option for not only presenting and using data on a dashboard in the fischertechnik cloud, but also to be able to use and display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. And these, of course, ship as part of the assembled training factory and connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allow for the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. Now, unlike the previous 24-volt models that we've discussed, the new 24-volt Training Factory Industry 4.0 model includes access to a sample program. Now, in this case, the sample program was created specifically in structured text format, and it was designed for use with a Siemens S7 1500 PLC. And the coding that was done is available for download on GitHub. Now, of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes adjustments to the sample program. And because of this, the source codes needed are also available for download from GitHub. And again, this is all free. This is included with your purchase. Now, all of the information you need for this model and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website, and which is also available from us upon request. So if you don't see where to access this, you can email me when I give you the email at the end of the presentation. Happy to send you this documentation. Also want to mention that as of last year, there are 2 additional versions of the 24-volt model, which are also available, and I'm going to discuss those 2 options when we provide an overview of the pricing in just a little bit here. Now, going back to the 9-volt version of this model, in the case of the 9-volt version of the Training Factory Industry 4.0, the control is facilitated through the use of 6 robotics TXT controllers. Now, again, with the robotics TXT controllers in the 9-volt versions, all programming is preloaded. In this case, it's pre-programmed using C, C++. And essentially, once all the connections to the internet are made and the cloud-based dashboard are made, all of which are clearly outlined in the documentation which accompanies the 9-volt version, you should be able to get started pretty quickly. The one thing you would need is 3 120-volt power adapters in addition to that. And I should also mention that it should go without stating, but I'll say it anyway. Whether we're talking about the 9-volt version or the 24-volt version or any of the models ahead of us that talk about an internet connection, it's also, of course, required that the end user, of course, have the ability to access the internet, as well as a tablet or a device for accessing the cloud-based dashboard. Just want to let you know that as well. Just to finish up a couple other things, the dimensions for these models are approximately 39 by 31 by 16 inches. They have a weight of approximately 51 to 53 pounds, depending on the version we're talking about. And again, we do recommend the optional travel and storage case to help protect the model during transport or storage. And that's the Training Factory Industry 4.0 model. Again, it is available in a 9-volt and a 24-volt version, but we're not quite done yet. Next model we're going to look at was a late edition. It came out last year, and this model incorporates the cutting-edge technology that's quickly becoming a part of our daily lives. And of course, by that I mean AI. The quality control with AI system model from Fischer Technic is ideal for visualizing this complex subject area in a hands-on manner as it creates a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation standardized. So what you have here is a Fischer Technic sorting line that comes with work pieces in 3 different colors, which you've seen before. But in this case, the work pieces are marked with 3 different processing characteristics, as well as various fault patterns. So what happens is the work pieces get scanned by the camera, and they get classified with the aid of trained AI. Now, depending on the color of the feature and the fault pattern, the work pieces are then sorted by the artificial intelligence on the basis of their quality features. The AI used is realized with machine learning and TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the Fischer Technic TXT 4.0 controller, and the model's sequence control is implemented in the RoboPro coding programming environment and in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications, and this training would be done in Python, and for which there's also a sample project provided for explanation. And that's the new quality control with AI model. It's an ideal training, simulation, and demonstration model for education and research and the visualization of AI-based systems, machine learning, and neural networks. Right now, this one is available only in a 9-volt version, with a 24-volt version anticipated for hopefully later this year or the beginning of 2025. In the case of the 9-volt version, which we are looking at right now, this uses the Fischer Technic Robotics TXT 4.0 controller, a little bit different than the ones we saw before. You can see by the screen on there that is able to capture the imagery. And as before, 120-volt power adapter is required for operation. Now, the next model we're going to look at is newly released, just came out at the beginning of this summer, and this is the Agile Production Simulation, which is the latest iteration of the factory model, this time not only incorporating IoT and state-of-the-art manufacturing processes, but also AI, and this time with a digital learning platform included as well. This factory of the future is the subject of numerous research projects in science and industry. Forward-thinking companies rely on automation, modularity, artificial intelligence, and agility to remain competitive. So in order to promote these topics in industry and research, students, apprentices, as well as, of course, employees, require the corresponding know-how and awareness to deal with these complex issues. And this is where the learning concept, agile production simulation, comes in. Now, it simulates basically processes such as quality assurance using an artificial intelligence. It has the functioning of a driverless transport system, and it replicates automated processes on a small scale, from goods receipt to the modular production to quality assurance. Now, the accompanying learning materials that come with this model translate the hands-on simulated processes into future skills for both students and teachers. And the digital twin of the model significantly intensifies the learning experience. Now, as we don't yet have a narrated video of this brand new model, we are going to have it soon. I'm going to provide you with a quick overview, beginning with the module where incoming and outgoing goods are placed. And this is, of course, where the material flow of a workpiece begins and ends. The raw material is delivered at the goods receipt slot, positioned on the color sensor for quality control using the 6-axis robot with a vacuum gripper. In that case, if you notice that, it's a 6-axis robot now, so this is a new feature as well. And then it's encoded on the NFC reader. The robot then places the workpiece on the automated guided vehicle, or AGV as we'll call it, for further transport. The module also contains the central control unit, which in this case is a Raspberry Pi, and the environmental sensor, which measures the different environmental conditions in the factory. There is also an integrated movable camera, which can be swiveled in 2 axes and provides an insight into the entire factory via the fischertechnik cloud-based dashboard, which of course we saw an example of in our previous factory video. Now, at the end of a cycle, a finished workpiece is delivered at the goods dispatch by the AGV. So this is again where it basically begins and ends its process. But the next step for a workpiece after goods receipt is usually the high bay warehouse. Although, because this is the agile production simulation, this could differ if there was a need for doing so. So you could actually send it to a different station as well. In any case, the high bay warehouse contains 9 slots for workpieces. It contains a stacker crane and a vacuum gripper that picks up the workpiece from the AGV at the docking station and hands it over to the stacker crane for storage. The workpiece is placed in a workpiece carrier for storage, and retrieval is done according to the FIFO first in, first out principle. You'll also notice that this is a different variation of the high bay warehouse than what we saw incorporated in the earlier models or in the standalone version. This is new for the APS model. Now, next you can move the piece onto a drilling station, which consists of a drilling station for the AGV, or a docking station, I should say, for the AGV, a vacuum gripper that places the workpiece onto a conveyor belt from where it is then transported under the drilling head. And after the simulated drilling process is finished, the workpiece is transported back to the gripper on the conveyor belt, and the gripper then places it back onto the AGV. Next up, you could go to the milling station, which consists of a docking station, as many of these will have for the AGV, consists of a docking station for the AGV, and a vacuum gripper at that station that places the workpiece onto a conveyor belt from where it is transported under the milling machine. There, the milling of 2 pockets is simulated, and after this process is complete, the workpiece is placed back onto the conveyor and transported back to the gripper. And the gripper, of course, then places it back onto the automated guided vehicle. Now, it can then go to the quality assurance module, which is a variation of what we just looked at with the AI model that we have for 9-volt. This is what they're incorporating here. In this case, the quality assurance module has a vacuum gripper that places the workpiece on a conveyor belt, and it's then, of course, transported underneath the camera and scanned there. The workpieces, which come in 3 different colors, again, red, white, and blue, with 3 different machining features, drilling, milling, or drilling and milling, as well as various fault patterns. And all of these are classified using the trained AI. Now, depending on the color, feature, and fault pattern, the workpieces are either placed back onto the AGV as okay, or they're sent to the reject container as not okay or defective. Now, the AGV transports the workpieces from one module to another. It's a track-bound vehicle that follows the printed black tracks. It uses ultrasonic sensors to detect any obstacles that may be in its way, and the vehicle itself has omni wheels which allow it to move in all directions. 2 buttons and a photo transistor help the vehicle dock to individual factory modules, and the AGV receives its driving commands from the central control unit, the industry standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power supply. When the battery of the AGV runs low, the AGV navigates towards the charging dock where it is automatically charged with a charger with charge monitoring. Contacts on the bottom of the charging station connect the AGV with the charging electronics. So some of the specifications you'll see here is the power supply is, of course, a 24-volt power supply unit, 11 amps. There's a central control Raspberry Pi 4B. Individual module control is the 5 SPS Siemens S7 1200s are included on here. So that's 5 PLCs are included. 5 SPS Siemens S7 1200s are included. There are also 3 TXT 4.0 controllers included, and this is for the sensors in the camera, as well as for the cloud access in the WEWA module for quality assurance with AI and for automated guided vehicles. It does have a WLAN router for the WLAN network. Software included is the SPS programs and structured text. You have TypeScript for central control on the Raspberry Pi. You have Node-RED for communication between the SPS and TXT 4.0 controllers. You have Python for programs on a TXT controller, and you have TensorFlow for supervised learning and quality assurance with AI mode. Again, there is also a digital learning platform included with a digital twin of the APS model, so that learning can be done with both the actual model as well as a virtual version of it. Now, we're going to have more details on all of this, as well as other aspects of the new model, along with a video overview of the model in action, available soon in a separate presentation. We're going to be announcing that hopefully very shortly. We're just waiting for some of the video to get completed. But for now, this gives you an overview of the Agile production simulation. I will also mention that there is talk of having add-on capability for this. If you see on the screen right now, you can see that some of the edges look a little bit like a puzzle piece. So I am hearing inklings that there may be the ability to add on additional stations later on, and there's also talk of having the possibility of adding another AGV to this as well. So if this is something that is of interest, again, this is something we're hearing hints of right now, so we're hoping to announce more on that soon. So with all of this being said, you might be wondering, so how much do these models cost? So now we're going to take a very quick review of everything we've discussed, along with the pricing for each option. So starting right at the top, we began with the conveyor belts. The 24-volt version, which of course requires the PLC and the programming, is $354.95 each. The 9-volt version, which includes the TXT controller, will require the additional power supply. That's $518.95 per unit. Punching machine with conveyor belt, the 24-volt version, $464.95, again requires the PLC and the programming. The 9-volt version that comes with the TXT controller is $599.95. The indexed line with 2 machining stations, the 24-volt version, $1,199.95. Again, PLC and programming are required. The 9-volt version has the 2 TXT controllers, will require the 2 power supplies. That is $1,394.95 per unit. The 3D or 3-axis robot, currently available in a 24-volt version and 9-volt. 24-volt is $1,059.95. The 9-volt version with the TXT controller is $1,369.95. Vacuum gripper robot is only available in a 24-volt version. That is $1,199.95. Of course, requires the PLC and the programming on your end. Automated high bay warehouse in the 24-volt version, $1,448.95. The 9-volt version with the TXT controller is $1,318.95. Multi-processing station with the oven in the 24-volt version is $1,287.95. In the 9-volt version with the TXT controller, it's $1,474.95. Sorting line with color detection, you're looking at the 24-volt version is $1,126.95. The 9-volt version with the TXT controller is $1,128.95. Only a $2 difference. The factory simulation model, the regular version of the factory simulation model, this is the non-IoT version. It only available in 24-volt at this time, and you're looking at a cost of $5,149.95. Again, this is the version where you have to provide the programming and you have to provide the PLC, the wiring, etc. Training Factory Industry 4.0, the 24-volt version. This requires PLC and, of course, the wiring, but it does come with the sample program and structured text designed for the Siemens S7 1500. That version is $9,498.95, and the 9-volt version pre-wired to the pre-programmed robotics TXT controllers, oddly enough, is also $9,498.95. But there are 2 more versions of the 24-volt factory. There is one that includes the PLC connector board and the cabling up to the connector board. This will save you a lot of time and a lot of headaches here to have that all, as you can see in the model or in the picture here, you can see the board. You're looking at a cost of $12,718.95 for this version of the 24-volt model. And there is another version that includes everything, including the Siemens S7 1500 PLC. So it's got all the wiring, the programming, the PLC. This is pretty close to being, as ready to use out of the box. Of course, once your connections are made, you have to do your setup and what have you, but basically including pretty much everything you're going to need. If you're in education, you have a cost of $19,319.95 per unit. If this is for a commercial customer, the cost is $20,124.95. So essentially, again, if you're looking at the version with the PLC connector board, you're looking at $12,718.95. And again, the version with the Siemens PLC S7 1500 connected to that, you're looking at a cost of $19,319.95 for educational institutions, accredited educational institutions, I should add, and a cost of $20,124.95 for commercial users. Other items. The 120-volt power adapters, which I mentioned several times that are needed for various models, are $12.99 each. The travel and storage case for the factory simulation and training factory industry 4.0 models that we've looked at is $1,524.95 per unit. The quality control with AI model, which we looked at towards the end there, only available currently in the 9-volt version. That, of course, comes pre-programmed, ready to go. You just need the power adapter with that. You're looking at a cost of $2,249.95. And we're hoping to have the 24-volt version available either later this year or early in 2025. And the Agile Production Simulation, this is only available in the 24-volt version. Again, this includes 5 Siemens S7 1200 PLCs and 3 TXT 4.0 controllers, as well as the digital twin. The cost for this model is $28,174.95. There is a special storage case made for this one, as you can see here. It's a little more involved than the first storage case. This one will come across, or the model itself is packed modularly. So you see that like different sections are placed in the case on different levels of the case. And you're looking at a cost of $4,024.95 for that. So with that all being said, if you did have any questions, this would be the time to type them in either the question and answer window or the webinar chat window on the Zoom toolbar. As I don't see anyone typing anything, I'm going to go right to the next slide, which will provide you on details on how you can take the next step. So if you would like to request a full color brochure and current pricing, if you'd like, a PDF version of that, if you'd like to ask any questions, if you'd like to request a quote on any of these models, if you'd like to speak with your dedicated educational representative, you can do all of those things by either calling us. Our number here in the US is 888-561-7521. You can also email us. You can just email us for quotes or more information. If you're not sure exactly who you should talk to, just email us at info@studica.com, studica.com. Just let us know, if you're a school, if you're a commercial user, what you're looking for, what you're interested in, what you'd like more information on, if you'd like catalogs or any of the manuals I mentioned along the way, again, just let us know. If you have any questions for me specifically about anything I talked about today, any aspect of fischertechnik, if you have more technical questions, which I may need to get help with, but anything of that nature, you can email me directly. And my email is lance.zurek, that's lance.zurek @studica.com. So on that note, I'd like to thank you again for attending today's presentation. We hope it was useful. We hope you're interested in what you saw, and we look forward to hearing from you soon. Take care and have a great day.